So we're going to have a look at 2019 open response question 17, pouring water. So Velma is filling cylindrical cups, here's my cup, with water from the jug below. The jug contains 1,900 or 1,900 cubic centimeters of water, and I would like to know, Velma would like to know, the maximum number of cups Velma can completely fill with water from the jug. So what we're doing is we're picturing in our mind the idea that we're going to take water from the jug and we're going to pour it into the cup. We're going to see how many times we can do that completely. So we're really thinking about how many times bigger is this jug than that cup. But I don't have all the information I need about the cup. I know the volume of the jug, that's the capacity of that jug, but I'd like to know the volume of this cup. And so that's where I'm going to begin. I'm going to think the volume of the cup. Well, that's the volume of a cylinder. When I think about a 3D shape like a cylinder or a prism, what I'm picturing in my mind's eye is the area at the base of this shape, and I'm picturing that area being layered on top of each other until we fill the top of the cup. So I'm thinking about the area of the base of that shape, and I'm thinking about the layers that have to go on top of it, which is represented by the height of that shape. I notice that the height is here, it's 10 centimeters, but I'm going to have to do some thinking about the area of that base. Well, it's the area of a circle, so I might have to look that up. And I'm going to find out that that is pi times radius squared, and I'm going to multiply that by the height, which I see is 10 centimeters in the diagram. So pi, we're going to use just 3.14. And radius squared, well, I'm going to look at the radius of that cup, which is the distance from the center to the edge. So that's 3 centimeters. And I know that when it says squared, what that means, that squared tells me I have to take that measurement and I have to multiply it by itself 2 times. The squared represents the 2 times that I'm multiplying that. So that squared tells me it's 3 times 3, 2 times, and I still have to think about that height, which is that 10 centimeters over here. And so when I multiply all those together, I get a value of 282.6 centimeters cubed. That cubed comes from centimeters times 10 centimeters times centimeters here with the 10 centimeters, and I know that volume is in cubic centimeters. So now we know the volume of the cup, 282.6. We're going to carry that forward. So the volume of the cup is 282.6 cubic centimeters. The volume of the big jug, that is several times bigger than the cup, was 1,900 cubic centimeters. So I really have to think about proportionally how much bigger the jug is than the cup. Some people might solve that kind of a proportion by looking at an open number line and comparing the number of cups. So when we have 1 cup, we know that we have a volume of 282.6. That's not an easy number to work with, so I'm going to start by estimating. I'm going to use a value of 300, and I want to figure out when I have a volume of 1,900, how many cups do I have? So I'm going to use my proportional reasoning, and I'm going to think, well, how many times bigger is 1,900 than 300? I'm not sure. But I do know that if I took 300 and I multiplied it by 2, I would find a volume of 600 cubic centimeters. And so if I had 2 cups, that's what my volume would be. Well, that's not anywhere close to 1,900, so I'm going to keep scaling up. Well, that was a pretty friendly number. I think I can take that one and I can actually scale it up by a factor of 3 now. So if I took those 2 cups and I scaled them up by a factor of 3, now I'm at 6 cups and I'm at a volume of 600 times 3, which is 1,800 cubic centimeters. That is really close to 1,900. In fact, it's only 100 away, so I couldn't fit another cup of 300 in there. So I'm going to say that my estimate for how many cups can be filled by that jug is going to be around 6. It's not exactly 6, but it's going to be around 6. And if I want to be more precise, I can use the actual values and I can say, well, let's have a look at this. I know the volume was actually 282.6. And I want to know how many times that volume can fit into 1900 or 1900. So I know I have to scale that up by some factor. It's not a friendly number. But I do know that 282.6 multiplied by some unknown scale factor is going to be equal to 1900. But I know that there's an inverse relationship here. I can also take 1900 and divide it by 282.6 to find out how many cups can fit in there. And when I do that, I find that it's 6.7. But when I go back to the question now, I notice that it's all about the number of cups she can completely fill with water. So I know that if we have 6.7 cups, that's actually made up of 6 whole cups plus 0.7 of another cup. This is not a complete cup, so I'm actually only interested in the complete cup, so my answer is going to be Velma can completely fill 6 cups of water.